Hi, welcome to my video on the unique product of two binomial radicals. The unique product. Let's observe what I'm talking about. Find the product of each. 3 times 3 is 9. 3 times negative root 5 is negative 3 root 5. And then root 5 times 3 is a plus 3 root 5. Root 5 times root 5 is a negative 5. And we add up the group like terms. This is 3 root 5. They cancel out and I get a 4. Let's go again. We're multiplying by FOIL. First, 1 times 1 is 1. 1 times root 3 is 1 root 3. Negative root 3 times 1 is a negative root 3. And negative root 3 times positive root 3 is negative 3. Group like terms. Done. And that gives me a negative 2. And they cancel out to give you 0. And continue. First, 36. Outside, positive 6 root 2. Inside, negative 6 root 2. Last, negative 2. In group like terms, and that gives me a 34, and they cancel out. 1 plus 1 is minus. And you can see, notice in these there's no radicals, no roots. Root 5 times 5 is 25. First, outside, inside, positive times negative is negative. Root 6 times root 6 is 6. 25 minus 6 minus 5 root 5 plus 5 root, plus, that's 5, that's a 6 there, my mistake. Gotta be careful. And they cancel out, and that gives me a 19. And one more FOIL. First, 16. Outside, negative 8 root 3. Inside, positive 8 root 3. Last, so we have a 2 root 3 times 2 root 3. Remember, positive times a negative is a negative. So 2 times 2 is 4. Root 3 times root 3 is 3. 3 4s are 12. So 16 minus 12 minus 8 root 3 plus 8 root 3. And you get 4. Notice I grouped them here, but if you wanted to, you could just cross those out right there and just add those two without writing this step down. Like here, you could have crossed these two out because they're plus and minus, and said 16 minus 12 is a 4, and omitted this step. But grouping them together is wise to do. Just be careful. Notice in each of the above, every one of them, there's no radical. There's no root in the answer. Each of the binomials above, each of these binomials are, as we say, irrational numbers. They have roots. They are not terminating, not repeating. If these are irrational numbers, 3 root 5 or 4 plus 2 root 3, they're all irrational numbers. 5 plus 6 root 6, they're irrational. Then notice their product is a rational number. A rational number, or we could say it could be an integer, it could be a fraction, but a rational number. What signs are changed in each from the first binomial to the second? What from the first binomial to the second one, what sign is changed? That's a 3 and that's a 3. Notice there's only the second sign changed to 1, 1. 1 is not changed. The minus is to a positive. The minus 6 is not changed, so plus to a minus. 5, 5 not changed, plus to a minus. Or it could have a minus to a plus. It's the second one that changes. Notice 4, 4, plus to a minus. So the second one is the second term is changed. So the second term, or should I say the sign of the second term is changed, not the first sign. Not the first sign. Compare the product of each above. Let's compare. Notice that this is x plus root 2, x plus 2, x minus 2. Notice this is 3, 3, root 5, root 5. Same as this, only these got should I say, literal coefficients. So x times x is x squared. X times negative 2 is negative 2x. 2 times x is 2x. 2 times negative 2 is negative 4. Notice that they cancel out and you get x squared minus 4. And the same here. You have the same two terms separated by a plus minus. So x times x is x squared. X times plus 3, plus 3x. Negative 3 times x, negative 3x. Negative 3 times 3, negative 9. They cancel out, you get x squared minus 9. If you notice, that's an x squared minus a 2 squared. That's an x being squared minus a 3 squared. So notice the product of these two are the difference of two squares. So let's go over and see. We can see the pattern. Find the product of each using the shortcut. So if you have a plus b times a minus b, then you're going to get, shortcut is going to get a squared minus b squared. They're the same two terms, ab with a plus minus. So if you did this out by FOIL, the middle terms would cancel out and you'd be left with a squared b squared. So the shortcut in multiplying these, notice that these are the same terms, 2, root 5 with a plus minus. So a fast way to do this, if you notice that there's, you go 2 squared minus root 5 squared. That would be 4 minus 5, which is negative 1. Root 5 times root 5 is 5. And again, there's the same terms separated by a plus minus. So you go 7 squared minus root 10 squared. 7 squared is 49 minus root 10 times root 10 is 10. You get a 39. And you have the same two terms again separated by a plus and a minus. So you get negative 4 squared minus root 3 squared, obeying this pattern. So negative 4 squared is 16 minus 3 is 13. And 5, root 11 plus minus. So that's a 5 squared minus root 11 squared. 25 root 11 squared is 11, and that gives you 14. That's the fast way if you can recognize it. But remember, if you forget that, do the FOIL first, outside, inside, last, and you'll come up with these answers. Based on that, we have what we call, these two are what we call the conjugates of each other. The conjugate of a radical binomial is the sign, is the change to the second sign, So when you take two binomials and multiply by their conjugates, as we have up here, then we will get a rational number. So notice the second sign is changed. Notice plus to a minus, the second sign is changed. Minus to a plus, changed. Plus to a minus, changed. But the first sign is not changed. The first sign is not changed. First sign is not changed. And the first sign is not changed, but the second one is. When that happens, we say we are multiplying by the conjugate. Therefore, we can use a shortcut or we can use FOIL. So the conjugate of this radical is change the second sign. 1 minus root 3. 4 minus root 6. Negative 5 plus root 11. Or this one is root 10 minus root 2. We change the second sign, not the first. Most teachers will change, in conjugates, will change the second sign, not the first. Practice means pause your video and work out the answer. So see if you can do the conjugate of each of these. Change the second sign. So it's 2 minus root 10. Root 5 plus root 2. Negative 8 minus root 13. 3 plus 2 root 5. 1 minus root 6. Again, the first sign is not changed. The first sign is the same. It's the second one, plus to a minus, minus to a plus to a minus, minus to a plus. We're changing the second sign when we do the conjugate. So that's what we call a unique product. When we multiply two radicals, binomial radicals, by their conjugates, we will get a rational number. Watch out for that product coming up in the near future in extra videos. If you like what I'm doing, click on the like button, the subscribe button, notification bell. Visit my math website, www.mathfullyexplained.com, to find more information about me, the videos, and the content. And hopefully you enjoyed my video. Thank you very much. Bye-bye.